If a reverse shell is where the target connects back to you, what happens when the target listens for you instead? Well, this is called a bind shell. So in my previous video, I used a vulnerable Flask app to demonstrate how command injection can lead to reverse shells, and today I'll be doing the same with bind shells. So let's just open a new one of these and get straight into it. So what is a bind shell? Well, a reverse shell is where it connects back to you when you execute some arbitrary command inside the target. Command injection perhaps, or some other type of vulnerability. But how is bind shell different, and what is a bind shell? So a bind shell is essentially this. We'll just run through it quickly and then we'll delve deeper. A target opens a listening port after I execute something like a Netcat listener, and then the attacker connects to that port and the attacker gets a shell. So essentially it's the antithesis of a reverse shell. So you can think of it like this. I write a listener and execute it on the target. It listens on a certain port and executes a binary like bin/bash, which means I get a shell. And then I go and connect to it from my device using something like Netcat or Python, whatever. And I have a connection. So the reverse shell, the target initiates the connection. But on a bind shell, the attacker initiates the connection. So it's basically the opposite. So let's dive straight in to how to do a bind shell with Netcat, with and without E. Alright, so now we've discussed what a bind shell is, we're going to cover how to set up a listener with Netcat. This video is for educational purposes only, and please use the content in here to help secure systems. Right, so this is our vulnerable Flask application. And we'll just play about with this. So as you can tell, this has command injection. I can do this. And this is because of improper sanitization when we're doing it. So there's a line of code which is responsible. Instead of just executing that, I can put a colon and execute something of my choice, like pwd. So that's standard command injection in a website, a classic vulnerability. So now, what if I did something like this? nc-nlvp8000-e/bin/bash. This essentially means set up a listener on port 8000 on local interface, which is available to me, and execute it /bin/bash, which is the binary. Now this only works when the E parameter isn't stripped. So we'll look at alternatives in a second if that is ever stripped. And I'm just going to execute this. And now we have a listener running. Okay, so now that we have a listener on this machine that I've executed this on, which is my vulnerable Flask app, I'm just going to connect to my IP address, which is this, on port 8000. So I'm going to just type nc, and then I'm going to type 8000, and we'll see what happens. As you can see, I have a shell. I'm connected on the device, and that's because we executed a listener on here, as you can see, and it executed the binary /bin/bash. And now I've connected from my device here, and I have a system shell, so I can execute commands on the system. So I essentially have compromised the machine now. Okay, so say that the -e parameter is stripped from the Netcat distribution. In this case we have a problem, but it's easily solved is the good news. So we're going to write 127.0.0.1, and in this case we're going to use piping instead. So I'm going to go to revshells.com. I'm just doing this in my other window, and here is a command that you're going to need to copy. So if you go to revshells.com and you go onto bind, you need the NC MKFIFO bind. That's what you need. And I'm going to guide you through this briefly. It's out of the scope of the video because it's a complex command. It essentially executes the bash file and pipes it through to listen on the local machine on port 8000. So it means we don't need the -e. So you can find this on revshells.com, the ncmuk FIFO command. And I'm just going to execute because that's as much into the command as we're going today. And now I'm just going to connect to whatever my IP address was. Sorry about that, my server just killed itself in the midst of this, which was very not useful. So as you can see, I've connected because it's executed this long, complex command using a different technique to the -e, because we've piped all of this along into this, meaning we don't need the -e, which has been excluded from one of the distros, and we can still execute commands. So now we can execute commands on the server. You may wonder why aren't bind shells used as much as reverse shells? Now that's what we're going to look at next. Okay, so we have a bind shell, that's great and all, but why do people like me always prefer a reverse shell to a bind shell? Well, let's have a little look. For starters, the connection differs. In our case, we're hosting it on the attacker. Now this is a problem because it needs to listen on the... Sorry, we're hosting it on the target. Sorry about that. We need to listen on the target. Now there's a problem because we've now got a service, a port, a process running on the target, which means that this could be detected by intrusion detection systems and following. So it's not good to have something running on the target, whereas with a reverse shell, it just connects back to us using one command, and we have a connection without a process actually running, listening for it. Now another issue we have is that firewalls can easily block it. It can drop outgoing packets, outbound traffic. So say the port 8000 is filtered, if we try and connect to that, anything we connect to it will be dropped potentially. So a firewall might prevent us from connecting to it. Another thing is network addressability. NAT segmentation and routing can often prevent the attacker from reaching the listening port because it could be hosting on a different interface that you're not aware of. But with mine, I can change my interfaces as I please, which is very useful. But it could host on localhost, and we might not have access to localhost because we might only have access to, say, F1, which is the public one we're connected to, or F2. So, or it could be on F2 and we need to be on F1. So there's problems there as well. And another thing is it's very discoverable. A listening port can potentially be discovered through network enumeration using tools like Nmap. Now let's just scan my localhost quickly, and I'm going to demonstrate this. Nmap. I'm going to... Well, what was my IP address? Nmap 192.168.1.156. Let's scan it. So as you can see, I put the T5 there to speed it up, but we've got port 8000 open, and that's purely because we've got a Netcat listener on this machine. Currently I've killed the server because we don't need that at the moment, so that would be on port 5000, that would show there, but port 8000 is open because we're connected to it with a Netcat shell, so it's very visible. So now that we've looked at why they're not as good as reverse shells, I want to point out that they're always worth a try if a reverse shell doesn't work. Always give it a go. But you must be very careful in pen testing, particularly. On a CTF it will probably work. There's very little firewall to none. But in a pen testing environment you need to be very careful, and bind shells are absolutely not recommended in the slightest. They're rather a theoretical thing. now we're going to look at how to stabilize a shell in the case that it's unstable and isn't working very well. And we just want a proper shell. So we're going to look at how to stabilize it using Python and various tools. Okay, so now we're going to look at mitigating potential problems with bind shells. So say, what if Netcat isn't installed on the machine? What are you going to do? Have a think about this one and come back to it. Or I would personally go and grab the next shell along. So if Netcat isn't installed, I might go and grab a Python bind shell. That would work. Or I might grab a Socat one if Socat is installed. I'm demonstrating with Socat today. I've grabbed a Socat bind shell from revshells.com. It's a weird type of shell. I'm not going to go into detail, but it works. It listens and I can connect to it. Python works as well. Ruby, Perl, PHP, all of those. If one isn't installed, try the next. This is just a demonstration. And as you can see, we have a nice shell. So it has worked with Socat. Socat is a bit of a fancy Netcat, basically. Okay, so now we know how to mitigate it. If a tool like Netcat that you love isn't installed, you can try another one like Python or Socat. I showed it with Socat. Now, this shell isn't great. How do we stabilize this? Because at the moment it's quite unstable. And the first thing we do is this. And this is a command you will just need to memorize because it comes over and over again every CTF you will ever do. And basically it spawns /bin/bash and gets us a proper shell. That's the basis behind it. I'm not going to explain in detail today. Now next, what if you want to be able to clear the shell like a normal shell because you don't want this? Well, you write export term equals xterm and you're just updating the environmental variables. Oh, whoops. And now you can clear the shell. So you can stabilize it using the classic Python 3 command with import pty.spawn /bin/bash, and it gets you a nice proper shell, proper interactive shell. You might have this on it, but it's a lot better than before. And export term equals xterm allows you to clear your shell. So I hope this overview of bind shells today has helped. This is where we will be ending. And I hope you now have an understanding of bind shells, what they are, how they work, and why they aren't quite as good as a good old reverse shell.